Good day everyone. In today's video, we will share to you our knowledge regarding our topic, which is security and protection in operating system. Here is the contents of our topic. What is protection mechanism? Let me give you a brief explanation of it. Protection mechanism refers to a wide range of things depending on the text. For example, security. How to protect a computer system, device, or network from threats. Physical safety. How to protect people or things from harm. Legal rights. What legal protection are available for certain groups or situations. Next is threat and threat monitoring. Let me differentiate these two. A threat is anything that has the potential to harm a computer system, network, or data. These threats can come from many sources, including malware, hackers, phishing, social engineering, denial of service attacks, and data breaches. Threat monitoring. Threat monitoring is the process of constantly watching for and detecting threats to cybersecurity. This involves identifying potential threats, monitoring network activity, analyzing security logs, using security information and event management tools. Or SIEM, staying informed, improve security posture. Threats are ever evolving, so it's crucial to stay informed and adapt your security measures. Threat monitoring is an essential part of any comprehensive cybersecurity strategy. By investing in threat monitoring, you can protect your system, data, and reputation from harm. Attack techniques. Attack techniques are the method used to cyber criminals to compromise computer system, network, or data. These techniques can be categorized into various types, each with its own unique approach and target. Here's a breakdown of some common attack techniques. First, social engineering attacks. Examples of these are phishing, spear phishing, baiting, pretexting, and tailgating or piggybacking. Second, malware attacks includes viruses, worms, trojans, ransomware, spyware, and rootkits. Third, network-based attack, web application attack, credential and authentication attacks. Other attack technique. Attack techniques are constantly evolving, so staying informed about the latest threats is crucial. Understanding the various attack techniques help organizations develop effective defense strategies and mitigate risk. It's essential to implement strong security measures, including firewalls, intrusion detection system, and user education to protect against this threat. Next, authentication mechanism. So, what is authentication mechanism? Authentication mechanisms are the processes used to verify the identity of a user or device trying to access a system or resource. They're essential for securing access to sensitive information and ensuring that only authorized individuals or devices can interact with the system. Operating system, or OS, play a crucial role in protecting computer system and data from unauthorized access, misuse, and malicious threats. They implement a variety of mechanisms to ensure the security and integrity of the system and its resources. What is protection system in an OS? A protection system in an OS refers to the set of mechanisms and policies that control access to system resources such as CPU, memory, files, peripherals. Protection systems are essential for securing operating system and protecting sensitive data. by implementing a comprehensive approach that includes user authentication, access control, encryption, firewalls, antivirus software, and regular updates. Organization can significantly reduce the risk of security breaches and maintain the integrity of their system. And lastly, what is protection problem? Protection problem in OS are ongoing challenge. While OS offer robust security features, it's important to be aware of these potential vulnerabilities and take proactive steps to mitigate risk. A layered approach to security including user education, regular update, strong authentication, and ongoing monitoring is essential for maintaining a secure system. Now, we will now discuss the features of secure in operating system. Protection. Security is mostly about mechanism. How to enforce policies. Policies largely independent of mechanism. Protection is about specifying policies. How to decide who can access. What specification must be correct, efficient, easy to use, or nobody will use them.
Security in OS. Security of OS is an issue external to OS. Example of it are authentication users, validations of messages, malicious of accidental introductions of flows. What is protection in OS? Protection of OS is mechanism and policies to keep programs and users from accessing and changing stuff they should not do in external OS. So in protection of OS, we need to follow a policies so that we have protections in our operating system. We proceed in protections and security. For now, what is operating system? Operating systems are collections of objects, hardware or software. So we have example of hardware: mouse, monitors, keyboards, chips, video cards, and etc. So we have also examples of software, freeware, and application software. Each object has a unique names, so it's easy to access the set of operations in OS. The protection security. So only by those processes of authorized user allowed to do. So if you have a user, so you will have protection security correctly access. So we finished discuss about protection security. For now, we proceed in security kernel. What is security kernel? Also provides security interfaces among the hardware, the operating system, and the other parts of computing system. Implementation of security kernel. First, may degrade security performance one or more layer. The second may be large, and the third is low guarantees.
Security. The security environment, user authentication, attacks from the inside the system, attacks from the outside the system, and also the protection mechanism and trusted system. For sure, the security environment, they have a traits. They have a goal and traits. The one is a goal is a data confidentiality and data integrity, system availability. The threat, exposure of data, tampering with data, and denial service. And also, they have an operating system have goals. One is confidentiality and is ensuring that the information that is only accessible, that the authorized users not disclose to the unauthorized individuals. They have entities or processes. Also, they have a data integrity. Data integrity is involved to protecting the data from being the modified is unauthorized ways. They're either the malicious or accidentally. And next is they have availability. Availability is ensuring that the information as a users they have accessible and usable when needed by the authorized person or users. Also, they have what kind or what someone attempts to subvert that goes. They have a fun. Fun is the malicious pranks, or prank-driven attacks, and some easy of individuals or groups that attempt to break or bypass the security to measures for personal and access measurement or curiosity, or as the hacking or testing that they own skills. And also they have a commercial gain is they have a financial or competitive advantage. They have also to individuals or groups driven by the commercial gain that typically attempt to subvert the CAI straight to order to profit from the breach. Also, what kinds of intenders are there? They have also casual preying by non-technical users, curiosity. Also, they have a snooping by insiders. They have often motivated by curiosity or money. And also, they have a determined attempt to make money, and also may not even be an insider, commercial, or military exponent. And this is not very big business. Also, they have acts of God, fires, earthquakes, and wars is the really an act of God. Also, they have hardware and software errors, and also CPU malfunction, and this crash, and also they have a program bugs, and hundreds of bugs found is the most recent Linux kernel. Then also they have a human errors, data entry, and also wrong tape mounted. Also, we topic about user authentication. Authentication have thus the computer known who you are. Also, they have a use authentication to identify, like something the user knows, something the user has, and something the user is. This is must done before can use the system. Also, they have improved important from the computer point of view. Also, they have anyone who can duplicate your IDs is you, and also by falling in a computer isn't all that hard.
Authentication using password. Do you see on the screen that we have three boxes, which is login, admin, password, admin, welcome to Linux. Login, user not found, login, admin, password, invalid password. Login, success login, let the user in. If things don't go so well, login rejected after the name entered. Login rejected after name and incorrect password entered. Don't notify the user of user incorrect username until after password is entered. Early notification can make it easier to guess valid usernames. So, in simple words, if both the username and password are correct, the user gets access, and if the username is wrong, it won't immediately tell the user. Instead, it waits until a password is entered to notify the user that the login failed. The purpose of this is not revealing valid usernames too soon prevents attackers from easily guessing which usernames exist. This makes it harder for hackers to break into the system. For example, you type the correct name and code, the door opens. For example, name John, code 1234. The result is you get in. If you type the wrong name, it won't tell you right away. Example of Windows XP. Security is based on user accounts. Each user has unique security ID. Log to ID creates security access token. Includes security ID for users groups and special privileges. Every process gets copy of token. System checks token to determine if access allowed or denied. Uses a subject model to ensure access security. A subject tracks and manages permissions for each program that a user runs. Windows XP uses a system to keep your computer safe by controlling what users can do. In short, Windows XP uses these tokens and IDs to make sure each user and program only accesses what they're supposed to, keeping the system secure. Authentication using biometric. Use basic body properties to improve identity. Examples include fingerprints, voice, hand size, retina patterns, facial features, potential problems, duplicating the measurement, stealing it from birth. User policy, restricting access, command file access, login times, network access, terminal access, inactive users, password change, locking or change shell, deletion or after backup. Ultimately need multi-level security. User policy is about setting rules to control what users can do on a computer or network to keep everything secure. In short, user policies are about controlling access, managing inactive accounts to maintain security and protect important information. For example, in restricting access, staff can only access the office network, not other company branches. In managing inactive users, if an employee hasn't logged in 3 months, they must change their password. And last, in multi-level security, these restrictions work together to protect company information and prevent unauthorized access. Multi-level security. Users with different needs to know sharing computer or network, if don't need to know, shouldn't even be able to determine if information exists. Should be able to filter functionality based on allowed information, mandatory and discretionary protections. General schema. Takes users' requests, consoles, access, control informations, allow or disallow requests. Advantages, easy to implement, easy to understand. Disadvantages, bottleneck in systems, controls only direct accesses, not inferences. A general schema works by first taking the user request, like accessing a file or program. If then, checks the access control informations or rules about who is allowed to do what. Based on that, either allows or denies the request. Very security model. Information is ranked: unclassified, confidential, secret, top secret. Least privilege should have access to fewest objects needed for successful work. The system backup program may be allowed to bypass read restrictions on files, but it would not have the ability to modify files need to know. This image explains different ways computers' viruses can exist within executable program files. An affected program, the first column shows a clean program with its structure consisting a header or blue, and an executable program or yellow. The program operates normally. Virus at the start of the program. The second column depicts a scenario where a virus or pink is inserted at the beginning of the program. The virus modifies the starting address to run itself before allowing the original program to execute. Virus at the end of the program. The third column shows a virus added to the end of the program. The original program runs first and the virus gets executed afterward. Virus in programs free spaces. The fourth column demonstrates viruses residing within the unused or free spaces of a program. This method is stealthier since the overall file size may not change significantly, making detections harder. This diagram highlights how viruses can embed themselves deeply in the operating system by targeting interrupt and trap vectors. It also shows the dynamic struggle between the virus and the operating system, emphasizing the complexity of virus behavior and the challenges in removing or neutralizing such infections.
Principles of protection. Guiding principle. Principle of least privilege. Programs, users and systems should be given just enough privileges to perform their task. Authentication mechanism. basis of most protection mechanism, two types of authentication. External. External verify the user, usually username or password combination, may require two password or other identification. Internal. Verify the process. Don't allow one user's process to appear to be that of one another user. Is this user process allowed to access the resource under the current policy? What type of access is allowable? Read, write, execute, and append. Virus dropper inserts virus onto the system. Many categories of viruses, literally many of thousands virus. File, boot, macro, polymorphic, source code, encrypted, steal, tunneling, multipartal, and armored. Program threats. Trojan horse. Code segment that misuse is environment. Exploit. Mechanism for allowing programs written by users to be executed by other users. Spyware. Spyware pop-up browsers windows, convert channels, trapdoor. Specific user identifier or password that are circumstances normal security be included in the compiler. Logic bomb. Program that initiates a security incident under certain circumstances. Stack and buffer overflow. Exploit a bug in a program. Overflow either the stack or memory buffers. Trojan horses. Free program made available to unsuspecting users. Actually, contains code to do harm. May do something useful as well. Altered version of utility program on victim's computer. Trick user into running that program. Kerberos network authentication. A set of network protocols used to authenticate access to a computer by a user at a different computer using an unsecure network. Assumes information over network could be tampered with, does not assume OS on either machine is secure. Develop a myth and it is widely used. The diagram depicts the Kerberos authentication process. Let's break down each step. First, the client request. A client, a computer or user wants to access a server, example, a database or application. Second, the authentication server's rule. The authentication server is a trusted third party that verifies the client identity. Third, ticket granting. Ticket granting. The authentication server, after verifying the client's identity, issues a ticket granting ticket, or TGT. Requesting a ticket. The client then uses the TGT to request a ticket to access the specific server it needs. This request is sent to the authentication server. Service ticket. Issuance. The authentication server, having received the valid TGT, creates a ticket for the requested server. This ticket contains the client identity and is encrypted using the server's secret key. Known only the server authentication server and the server itself. Secure communication. The authentication server sends the encrypted ticket to the client. The client in turn sends his ticket to the server along with an authenticator proof of its identity. Server verification. The server uses it to decrypt the ticket verifying the client's identity. The server can now communicate securely with the client because the client's identity has been unauthenticated. Session key. A session key is also created and exchanged during this process. This is a secret key used for secure communication between the client and the server during the specific session. This prevents eavesdropping during the session.
Service mechanism attacks OSI security architecture. Attack action that compromises the security of information owned by an organization, and also mechanism is also detect, prevent, or recover from a security attack. And also service is enhance the security of the processing system, and experts counter the security attacks. Also, the security as they have active threats. Also, that they have a masquerade, replay, modification of message content, and also denial of service. Some of modification of the data upstream. Also, they have a protection system. Protection system is a set of the objects, set of the subject, and also set of the rules of specifically protection of policy. Also, they have a present accessibility of the object by subjects, and also the grantees that they have protection state is the check from each access and an object by an subject. Also, they have to see the protection system. Also, they have a subjects. Subjects is as to desires a access to X, and also the object is also going to other side.